Welcome to the DIY Honda Garage channel. The DTC P2648 indicates a malfunction in the rocker arm oil control solenoid A, specifically on the intake valve side, for 2008 to 2012 Honda Accord models. This code often relates to the vehicle's variable valve timing and lift electronic control (VTEC) system, which is critical for optimizing engine performance and efficiency. The rocker arm oil control solenoid is responsible for regulating oil flow to the rocker arms, allowing the engine to adjust valve timing. When a low voltage is detected in this circuit, it signifies a potential issue with voltage supply or electrical integrity in the solenoid circuit. The fault can lead to decreased engine performance and increased emissions, making it essential to diagnose and fix promptly. Understanding this DTC is vital for effective troubleshooting and maintaining optimal vehicle function. The rocker arm oil control solenoid A is a key component located on the intake valve side of the engine. This solenoid operates based on oil pressure, allowing for variable control of the rocker arms linked to the VTEC system. When functioning properly, it adjusts valve lift, enabling better engine efficiency and performance. Its location is significant as it directly influences the distribution of engine oil to the rocker arms, affecting how the engine breathes and performs at different RPMs. The failure or malfunction of this solenoid can trigger the DTC P2648, indicating low voltage in its circuit. Without a proper signal and adequate oil pressure, the rocker arms cannot perform optimally, leading to potential engine performance issues. Several causes can lead to the DTC P2648 occurrence. A faulty rocker arm solenoid may fail to operate correctly, restricting oil flow necessary for the operation of rocker arms. Alternatively, wiring issues such as shorts, frays, or open circuits can prevent adequate voltage from reaching the solenoid. Additionally, a poor connection at the powertrain control module, PCM, can disrupt communication between the operational commands and the solenoid, leading to low voltage reading. Each of these scenarios needs to be thoroughly examined during the troubleshooting process. By identifying the underlying cause, effective repairs can be made to ensure the solenoid functions properly and the engine operates efficiently. The DTC P2648 can manifest several symptoms that indicate underlying issues with the rocker arm oil control solenoid. When this error code triggers, it typically causes the check engine light to illuminate on the dashboard, alerting the driver to a problem. Beyond the light, reduced engine performance is often felt, as the engine struggles to optimize valve timing and lift, which affects acceleration and power output. Additionally, drivers may notice increased emissions, as the engine may not be running as cleanly due to improper valve operation. These symptoms not only impact the driving experience, but also could lead to further complications if left unaddressed, emphasizing the need for timely diagnostics. The first step in troubleshooting DTC P2648 requires turning the ignition switch to the on-to position without starting the engine. This action enables the vehicle's onboard diagnostic system to power up and prepares it for diagnostic functions. It is crucial to record all freeze data and any snapshots stored on board, which can provide critical information about the vehicle's status at the moment the fault occurred. This data reflects operational conditions such as engine speed and temperature, which can significantly aid in pinpointing the issue. Additionally, reviewing general troubleshooting information is essential as it familiarizes the technician with specific parameters and recommendations that guide the diagnostic process effectively. The second step involves using the Honda Diagnostic System (HDS) to clear the DTC. This process resets the vehicle's onboard computer, allowing for a fresh start in diagnostics. By clearing the error code, you can check if the issue returns, confirming whether the problem is persistent or intermittent. Using HDS is crucial as it provides advanced diagnostic capabilities tailored specifically for Honda vehicles. Following this step ensures that any lingering faults stored in the system are cleared, setting the stage for more accurate testing and evaluations in subsequent steps. Properly using HDS guarantees that technicians can monitor the vehicle's responses effectively post-clearance. In the third step, the technician selects the VTEC test option within the HDS interface. This function allows for the activation of the rocker arm solenoid A, which can help determine whether the solenoid is functioning correctly under controlled conditions. By sending a direct command to actuate the solenoid, you can check for its response, ensuring that proper oil flow is established when activated. This active testing is invaluable, as it isolates the solenoid's functionality from other potential system failures. Observing the solenoid's performance in real time allows for immediate confirmation or denial of its proper operation, thus guiding the next steps in troubleshooting. The fourth troubleshooting step involves checking for any pending or confirmed DTCs using the HDS. At this stage, the technician needs to ascertain whether DTC P2648 continues to be indicated after performing the previous tests. If the code is confirmed, it indicates that the issue persists and further investigation is warranted. Conversely, if no faults are present, this may suggest an intermittent failure, which could be a momentary voltage drop or connection issue. The technician should then examine for poor connections or loose terminals at the rocker arm oil control solenoid A and the PCM to rule out any physical issues. The outcome of this check significantly influences the direction of subsequent troubleshooting actions. For the fifth step, turn the ignition switch to the lock position to ensure that the vehicle systems are completely powered down before proceeding. This is crucial for safe handling and manipulation of electronic components without risking shorts or other electrical issues. Ensuring that the ignition is turned off protects both the technician and the vehicle's electronic system during the process. Once the ignition is off, the technician can prepare to disconnect the rocker arm oil control solenoid A 2P connector. Proper disconnection is essential for subsequent tests, as the solenoid must be isolated to check its electrical resistance and continuity. Taking these precautions not only supports safety, but also enhances the accuracy of the diagnostics. In Step 6, the focus is on disconnecting the rocker arm oil control solenoid A by locating and removing its 2P connector. This connector is critical as it serves as the electrical link between the solenoid and the vehicle's wiring harness. Disconnecting it carefully is essential to avoid damaging the terminals or wiring. After removal, it allows for direct testing of the solenoid's electrical characteristics. The technician will need to inspect the terminals for any signs of corrosion or damage before continuing, as poor connections can falsely indicate issues during performance checks. A thorough inspection ensures that the tests performed afterward yield accurate readings, leading to effective diagnosis and repair. Step 7 involves measuring the resistance between the two terminals of the rocker arm oil control solenoid A's 2P connector. Using a digital multimeter, it is essential to ensure that the resistance falls within the expected range of 14 to 30 ohms at room temperature. This measurement confirms the solenoid's internal condition. Resistance outside this range may indicate a fault. A resistance reading below or above the specified range suggests either a failure in the solenoid or potential wiring issues. It's important to have the vehicle at room temperature for accurate testing, as extreme temperatures can affect resistance readings. Documenting this data is critical for evaluating the solenoid's functionality and guiding the next diagnostic steps. In Step 8, the technician jumps the SCS service check signal line using the HDS. This action prevents any interruption in the diagnostic process while testing for faults within the circuit. By connecting the SCS line, you can ensure that the diagnostic system performs checks without interference. This is particularly important because any voltage or signal disruptions can lead to erroneous test results. Jumping the SCS line allows for focused testing of the electrical pathways without the risk of miscommunication between components. Following this step, the technician can proceed confidently to check further components and connections, ensuring a systematic and thorough approach to troubleshooting. The 9th troubleshooting step requires disconnecting PCM connector B, which consists of 49 pins. The PCM, or Powertrain Control Module, is the vehicle's central computer managing engine and transmission functions. Disconnecting this connector is essential for assessing continuity between the necessary terminals and body ground. This step ensures that we can eliminate any potential faults originating from the PCM side of the circuit, which could contribute to the DTC P2648. Proper handling of the connector is crucial to avoid damage while ensuring a clean connection for thorough testing. After this disconnection, the technician can accurately assess continuity and pinpoint any issues along the wiring harness. In Step 10, the technician checks for continuity between PCM connector terminal B35 and body ground. This assessment verifies whether the wiring between the PCM and the rocker arm oil control solenoid A is intact. Continuity indicates that electricity can flow through the wire without interruption, which is critical for proper solenoid operation. If continuity is confirmed, this shows that the wiring is sound and there are no shorts or breaks. However, if continuity fails, it suggests a short circuit in the wiring or a cut in the cable, requiring further investigation and likely repair. Accurate continuity checks are vital to ensure the electrical system operates as designed and to address any issues effectively. After completing all necessary repairs related to DTC P2648, a final verification step is crucial. This involves carefully reassembling any components that were removed during the diagnostic and repair process. It's essential to ensure all connections are secure and that no tools or foreign materials are left within the engine bay. Following reassembly, the technician should start the vehicle to confirm that the engine operates smoothly and that no new error codes arise. This final operation verifies not only that the repairs were successful, but also that all systems are functioning correctly, ensuring that the vehicle remains free of DTC P2648 after repairs confirms the effectiveness of the interventions and enhances driver confidence. Preventive maintenance is critical in avoiding issues like DTC P2648 in the future. Regular oil changes are highly recommended, as clean oil is vital for proper solenoid operation and can significantly impact performance and longevity. Additionally, routine monitoring of engine performance can catch potential issues before they escalate into more significant problems. Using high-quality oil and adhering to service intervals can prevent deposits and contaminants from affecting the rocker arm oil control solenoid and other related components. Conducting regular inspections ensures that wiring and connectors remain intact, reducing the likelihood of electrical failures. A proactive maintenance approach leads to improved engine efficiency and reduced repair costs over time. In conclusion, DTC P2648 signifies a low-voltage condition in the rocker arm oil control solenoid A circuit, significantly impacting engine performance. Understanding the role of the solenoid, the wiring integrity, and related components is paramount in effectively diagnosing and repairing the issue. A systematic troubleshooting process can lead to the identification of faults and the necessary corrective actions. Emphasizing regular preventive maintenance, including oil changes and routine performance evaluations, can help prevent such DTCs from occurring in the future. By paying careful attention to these factors, vehicle owners can ensure their Honda Accord remains reliable and performs optimally over time. Please like and subscribe to the channel. See you next time.